Hello, everybody. Welcome to the part 4 of the continuous thermal monitoring series. It's great to have you all here with us today. My name is David Gray. I'm the head of marketing at Exotherm. This will be the final stage of our 2024 CTM webinar journey. So great to have you on board. Today, the team will be offering insights into how you can maximize resilience in critical electrical assets. And they'll be discussing how predictive maintenance is becoming a standard approach. So whether you're in the energy industry or data centers or mining or critical infrastructure, this is for you. We want the session to be interactive, so please get involved. Use the chat functions. The team will point that out where you can chat within the interface in the next few slides. Do take part in the polls. They'll be popping up on screen. Your feedback is really valuable to us. And then, of course, at the end, there'll be a Q&A session. So ask questions throughout. Don't wait to be asked. Just pop them into the chat facility. So if there's anything, even if it's on the fringes of what we're talking about today, do ask those questions and we'll try and get back to you. And if we don't get to your question today, what we'll do is we'll compile them all in a Q&A fact sheet and then distribute them to everybody that's signed up to the webinar afterwards. So we'll begin once you're all settled in. So grab a coffee, sit back and enjoy. We've got two experienced electrical sector experts on hand in Atul and Caroline. They'll guide us through today's session. So
Morning,
without
everyone.
further delay, I'll pass you over to our host of the session. Welcome, Atul, Caroline, over to you.
Thanks, Dave. Thanks for all those kind words. So as we said, in terms of questions, David was saying, please raise as many questions as you like, even if it's not related to this webinar that we're going to do today, but please, all questions are welcome and we will answer them to you, of course, after this session as well, or in writing when done. So if we move ahead, there's also polls. We also want your feedback, going through this webinar. So there'll be 3 poll questions where we want you to answer for us. So please hit those poll questions, submit for us so we can see how that rolls forward, so we can then take your suggestions and advice moving forward on some of the topics that we will raise with you today. So if we move forward into the agenda for today, really we want to cover a couple of topics. First, just around industry trends and forecasts. Where do we see the market going? A quick recap over webinars 1 to 3 to help a lot of those to orientate you in terms of what was discussed. Quick product solution and application overview with some real life scenarios. And then, of course, with some references from some happy customers and with some key takeaways. And we'll end with a Q&A session going forward as well. So please, guys, remember those questions. So really, let's look at industry trends and drivers. So, why do we see sensor technology becoming such an important part in condition monitoring systems? And really, there's 3 trends. And if we start on the left-hand side, in one of the surveys, it states that still 70% of customers are running their plant to failure as a maintenance system. And at least 70% are seeing at least one unplanned downtime in a month. So of course, with sensors now in your system, you can really move from running to failure really to a predictive maintenance system, which of course will improve your system uptime and reliability. So sensors are starting to become a real integral part of any maintenance system going forward. If you take the centerpiece, keeping your people safe, I think that's a fundamental. I think all end users out there, that's the number one thing that everyone wants to do. And we see designs in all the switchgear to help keep our people safe. But if you have sensors installed and you're getting that data 24/7, 365, you don't need to send people in anymore to take readings or do thermography, etc. So you can really keep your people safe. And of course, if you can detect anomalies earlier as well, by having sensors, you can prevent catastrophic failures, so thereby keeping assets and personnel safe. So sensors play a role in both of those. And then on the third one, when we talk about sweat assets for longer, this is really, I think, we see this in the industry. People have old assets, and then they've got sustainability and circularity goals that they need to meet. But by adding sensors, you're able now to get all that data and understand which of those plants you can build a plant refurbishment plan based on the data that you're receiving to help you refurbish, meet those sustainability and circularity goals that you have as an end user. So sweating assets for longer, I think, is a big topic that many of our end users are finding themselves with. So sensors really help us in that. So if we look at, we see that research analysts are starting to also get into this and are coming out with many forecasts and research topics around this. So now what we see is, if we look at this graph, they are forecasting around switchgear monitoring systems, basically starting with temperature monitoring, partial discharge monitoring, gas monitoring, other systems, which includes ambient humidity, etc. But in millions of dollars, they're saying that temperature monitoring will see a compounded annual growth rate of around 8.6%. The others tracking very close as well. So it shows a huge growth above market expectations. In millions of dollars, the expectation is that the temperature monitoring piece will be around $1.2 million in 2028. And what we can see from that is that the largest share of wallet is going to be added to temperature monitoring. So 43% of that pie will be for temperature monitoring. And this is understandable, I think, in a way. We can see the trend because 1 in every 3 electrical failures we have can be attributed to loose connections or compromised joints. And to be fair, we in Exotherm are seeing that growth by the demands, the questions we're receiving, the customers that are approaching us to look at temperature monitoring systems, continuous thermal monitoring systems for their plants.
It's actually quite interesting statistics, and I guess it would be interesting to know from everyone that's in the call today who's actually working on old methods of thermography and versus how many have actually sort of already been converted. This isn't a poll question, which is unfortunate because I think it would have been interesting. So maybe we can do that for the next one. But where we are in terms of thermography has changed significantly over the last few years, and probably since COVID, in all fairness. We're now in the predictive, we're now into the digitalization phase, and I'm sure all of you have heard the word digitalization or Industry 4.0. If you haven't, then where have you been? Because this is everywhere, in every conference, in every webinar, everybody talks about digitalization. But for anyone not quite understanding what digitalization is, it's all about the ability of building intelligence into your asset. We're giving your asset some life. We're planting some eyes inside of the equipment, and then we're just having a little look around. And then the same technology, and where Exotherm is concerned, we're talking about the sensor technology to detect heat. Heat tends to be the first indication that you have a problem. So based on digitalization, we're installing sensors into your equipment, and these eyes are going to monitor critical joints and cable connections. Now, when you get to the point where you want to move into digitalization and have predictive maintenance, which will give you the ability to have remote access into your equipment, then you need to look at the next vital step, and that's changing your specification. Because if the specification doesn't ask for it, then you'll be working on old methods of thermography. So all these prestigious new projects, you'll be working on old methods. So now you've moved and you're making that step forward. And I promise you that when you look look at your sensors, you'll have a whole raster of options on the market. Okay, I thought my next slide. So you will have an avalanche. And as the customer, you have to be smart here. You have to be cute. You have to put position to be asking those important questions, because you could get blindsided by, yes, there's a hotspot detection system included, but you should be asking questions. You want to know over the life of that asset if anything needs to be done Do I have to replace anything? Do I have to maintain me in any way? Do you have to do routine inspection? Do I have to be recalibrated? If I have batteries, do they need to be replaced? Because if they do, over the life cycle of that asset, then you are going to have incremental maintenance costs. But it's not just the fact that you're having to do it, it's the downtime that you need to sort of move to actually maintain that system. Now, predictive maintenance should save you about 30% in your OPEX. But if you have to maintain them, you'll have no cost saving. Now, over the last 3 webinars, we've tried to sort of touch on important features to look at. And when you look at the job of the sensor is there to collect that valuable data so that you can use it to analyze the performance of brands, for instance. So the sensor is the important part. You want something that's easy to install and easy to commission. Exotherm, we commissioned in the factories from new build, or if it's a retrofit, then yes, they're commissioned at site. But from a new build perspective, anything that you have to commission at site will ultimately add cost and a delay to get that equipment installed. We talk about vendor neutral. Vendor neutral is so important because we're not just looking at one switchboard or one asset. We can fit into any brand of equipment. So you want it all to sort of fit together. When we talk about webinar 2, we talk about contact versus or non-powered versus powered. Non-powered means that you never need to have the sensors recalibrated. We calibrated for life. Anything that's powered, you will need to do that recalibration. We're also hardwired, so we are not wireless. People ask us all the time, why aren't you wireless? Wireless sensors come with a whole different rafter of instructions because you have to maintain them. You have to replace parts, you have to do inspection. Also, the majority of wireless sensors, they actually use Zigbee technology, which globally is recognized as the most hacked protocol. So why would you put yourself at risk? We also work with open protocol. So we're working with Modbus 485. We're a non-contact solution, so at all times we are never in touch with anything live inside of that switchboard. So non-contact means that we work with local standards and international standards. So we fall in line with creepage and clearance distances. And everything about Exotherm is non-maintenance. Lifetime calibration, and on some of our products we give you lifetime warranty. Webinar 3, we talk about the all-important delta T. We talk about rise over the ambient. So we're not giving you absolute temperatures, which some of you work in a really high ambient region. Okay, so taking the ambient out of it, working on delta T is the most reliable, recognized means to find a compromise in your equipment. And this webinar is all about cost. It's all about what is going to benefit you, because we always get asked, what will be the cost? What is in it for me? So we're looking to inform you how you can gain over the life of your asset. And then we talk again about vendor neutral. Vendor neutral is the instrumental part that actually links all of your assets together and gives you a uniform quality of data. Okay, I think we're running into a question now, are we? Okay,
Thanks.
over to you, Athol.
Thanks, Caroline. Yes, so thanks, guys. We'll launch a poll. If you could give us your comments and maybe the points in terms of how do you view the role of continuous thermal monitoring, or aka CTM, in predictive maintenance for industrial assets. So if you could launch that poll for us, Caroline, and get everyone's answers. So thanks, everybody.
So just to re-emphasize that question, how do you view the role of continuous thermal monitoring in predictive maintenance for industrial assets? Do you find it essential, helpful, limited value in my industry, or you're not familiar with continual thermal monitoring. So encouragingly, does that show your side, Athol? Yes?
Yeah, I can see it. Thank you.
Right,
Yeah.
okay. So 57% see it as essential, which is good to see. 33% helpful, limited value in my industry. So I guess it would be interesting to know what those industries are. And 6% not familiar at all with continual thermal monitoring. So if those people want to reach out to us, and then I'm sure that we can be jumping all over you with lessons on continual monitoring. Okay.
Yeah, lovely. Thanks everyone for your answers there. So if we roll forward, and we really want to take you through Exotherm's product range, and Exotherm's product range is we work by the motto, keep it simple. So we have a small product range, but the applications that we can play in is really huge. And starting on the top, if we look at what we call our delta T sensors, and Caroline spoke briefly about that. So we have an infrared sensor and we have a cable sensor, and really, the main aims there is that this is equalized by design for ambient temperature. So wherever that ambient is, where that sensor is set, you're getting a true sense of what's happening in that object that it's measuring. So again, hardwired, no power, non-contact, which means no maintenance and no calibration over the lifetime of the asset. So these two products predominantly, as you say, would play in wherever there's a bare copper or bare aluminium bus bar, you can measure it with the delta T infrared sensor. On the cable sensor, the name speaks for itself, measuring the temperature across the cables, also providing you with a delta T. Rolling into our MCC temperature solution, this comes standard with a loom, with an LED, a Modbus data card, and an aggregator card. And really what we're measuring here, either 3-phase 3-wire or 3-phase 4-wire systems that can be installed on your incoming and outgoing connections or stabs for your bucket or your drawer. And of course, with that, providing you with measurements across each of your phases, comparing those as well. And the LED would be, if you don't have a BMS or SCADA system, you can use an LED system where this will flash according to what's happening. If it's all green, normal, yellow flashing, red, it'll tell you how many flashes and which phase you're having an issue on. So this can be all daisy chained back via Modbus. And as you can see on the Delta T and the infrared sensors, we have a Modbus data card that you install it to, and everything can be daisy chained back to your front end system. On the bus duct solution, we have a standard bus duct solution where we would measure same with the looms, with Modbus data cards, an LED for indication, and everything can be taken back via the Modbus RTU. So if we have a look at our integration options, Modbus is a really industrial standard. It's reliable, it's reliant, and of course, if you look at the top drawing, this is if you go straight from the sensors back to the front end system. So via raw data, Modbus 485, or you can convert it to whatever you want, TCP/IP, Profinet, Profibus, etc. The second section at the below is if you want to have a local HMI as well. The integration options is you would daisy chain into your ARM-XL, and this would then give you information pass through and then send everything out via TCP/IP to your front end system. But with the local HMI, you'd get load related alarms with local and remote alarms as well. So integration is simple, it's easy, it's a reliable standard, and so everything can be daisy chained and taken to your front end system. So if we roll forward now into some of the applications, and I think this is where we really see the measure of the product. So in MV switchgear, we predominantly use the infrared sensor and our Modbus data card. And if you took a typical AIS solution, we would mount these sensors. The red dots are of course denoting the sensors, the infrared, above the cable compartment below the VCB for incomers and feeders, above the VCB, and then in the main bus bar section as well. So considering that would be 8 sensors, our Modbus data card is 8, But of course, we do have customers who want to have more measuring the cable compartment itself. So you can use as many sensors as you like in there going forward. As we said, infrared sensor, wherever there's a bare copper or aluminium, we can measure that with the infrared sensors. And other applications for the infrared sensor would, of course, be UPS, PDUs, and DC traction systems as well. The infrared system comes into its own. Moving forward into low voltage switchgear, the low voltage switchgear is a nice comprehensive range that we have that we can play with in an LV switchboard. So if you take this switchboard per se, and starting on the left-hand side, looking at the red dots for the infrared sensor, we would start it, of course, on the incoming side of the ACB, outgoing side towards the main bus, on your red dots in terms of your transport splits, and then, of course, any ACB feeder that you have as well, where you have bus bars leading out, we would use the infrared sensor. The yellow dots denoting your cable sensors, of course, any feeder out from your ACBs to the plant, or any feeders, or any even motor control. You could also use your yellow dots, your cable sensors out there as well. Predominantly, we see on ACBs, there's always more than one cable feeding out to the plant. So you could use the cable sensor as a more cost-effective solution there. Then the blue dots, of course, denoting for the motor control center buckets or drawers that you have, you would fit them in there. And then, of course, everything daisy chained back from that via the Modbus RTU to your front-end system. And the bus duct on top, the green dots denoting measuring each of those joints that we have for the bus monitoring solution as well. So a nice comprehensive full solution for low voltage switchgear. So if we roll forward, and now we go into a real life case scenario where we were approached by one of the large MV drives and soft start OEMs and said, look, he has a customer, he wants to move away from thermal imaging, and what we're providing today is 3-hour sensors, basically 3-hour windows, basically positioned across the incoming cable, the incoming VCB, and the outgoing connections. What could you guys do to support that approach? So what we did was taking out the 3-hour windows, which were from a renowned brand. We're taking those out, replacing that then with 9-hour sensors, 3 on each, for each of those where the hour windows were positioned, 2 Modbus cards, and they would take those signals back to their own onboard HMI, which links to the plant's SCADA system. If you're looking at a hardware cost, and I think this is where I was pleasantly shocked, was when we looked at the hardware costs. The cost of the hour windows was $1,900 for the 3 of them. The exotherm sensors and the Modbus cards came in at $1,970. So $70 difference on the initial hardware costs for 24/7, 365 data coming back. So moving forward, we had to then, of course, take some considerations with the end customer in terms of, kind of how long does the lifetime of the switchgear, what does he want it to last for? How long would it take for him to install those windows? We reckon about an hour. They do thermography. What does it cost for a thermographer in the report? So they came up with it costs them $500, and they do it twice a year. So if you think of it, 2% of the year, they're actually looking to see what's happening. The rest of the time, it's just pure luck. Their labor cost was around $160 per hour, and the time to install the exotherm system was around 6 hours and commission. And then we also looked at the window replacement for the IR windows, and these things do degrade. The crystals degrade, they deteriorate, and environmental conditions play a big part in that. So dust, temperature, humidity, etc. So we took it on 10 years, which may be a bit long, but we took it on 10 years, and we rolled into the ROI calculation, which is quite a bit to read when you look at it. But the main thing that we take out of here, if you roll to the next slide there, so if you look at it, taking CapEx alone and installing the windows versus the exotherm solution, $910, there's a print, sorry, $910 is a difference in the overall CapEx savings. So exotherm comes in at $910 more in your initial install. But rolling forward, you have to replace those windows every 10 years, we said. So year 10 and year 20, you replace those, bringing in a saving of $3,200 just on your capex. So on your capex cost $3,200, maybe doesn't sound big, but if you're using in a plant and you're having 10 or so of these drives, it starts adding up. The big cost or the big saving for the end customer was really in terms of the scans. He doesn't have to scan twice a year anymore. That's $1,000 per scan per year, giving him a $25,000 saving, rolling into $28,000 saving for one drive. So considering on some plants they have more than 10, it starts becoming substantial. And also note, please, these savings do not include, downtime resulting from maintenance or calibration of the windows. And remembering that sensors provide you at least they give you a reduction of 70% in terms of unplanned downtime of outages, because you know what's coming, you see it, and of course a lower risk of any catastrophic events. So that excludes those savings, which is sometimes, as you say, maybe difficult to be able to put forward, but a substantial saving for the customer was brought in with that. So thanks.
I think people forget as well that you have to maintain windows on the inside as well, so
Yep.
which adds additional costs. So okay, thank you, Athol. So we're moving on to transformers now, and specifically here we're looking at dry type resin cast transformers. Now, when you receive a transformer, it's already kitted out with a whole bunch of sensors fitted inside the transformer, which obviously is from the manufacturer. But transformers still fail. And our experience has found that the problem is actually with the resin itself. So by monitoring the resin, and we're looking at resin posts here, we're talking about the coil tap changes, by using infrared sensors fitted in vertical plastic strips and obviously the data card, we can actually monitor those critical areas on your existing transformers actually. Supply chains have still not recovered since we had the COVID. And so hanging on to your existing assets for much longer is certainly something that we talk a lot of end customers, and this is what they're doing. So we have a case study here. This one was with an army barracks. Customer had 9 transformers, of which 5 experienced catastrophic failure. And the client was generally concerned that he'd got a faulty batch, and he wanted to hang on to his other 4 transformers. So we came in and we fitted our sensors, and as per what I just said, we fitted 9 infrared sensors onto the HV side, and we mount them in the vertical plastic strips, and those strips are placed on the inside casing that goes around the transformer. So we're not touching the transformer, we're not impacting on any type test, we're not touching it in any way, but we are using the sensors to monitor these target areas and allow them to 24/7 monitor. Now, the good news for us and for the customer, actually, 5 months after the sensors were installed, customer notified us that actually one of the coil tap changes had started to show similar signs to the way that the other previous 5 transformers had failed. So he was able to do something about it. He was able to redirect the load to slow down the actual failure, and he was able to get the repair done. He still has those 4 transformers now. So we had 9 sensors on the HV and 4 on the LV side. Now, when you look at the cost of that investment, basically he's saved his transformer. He had 13 sensors, 2 data cards, a bunch of brackets, 1 day downtime. It cost approximately $5,000 to look after that asset. Had he have lost it, it would have been approximately in the region of $35,000 per transformer. Okay, so if the other 4 did follow suit, then obviously your costs are now rising. But it's the extended wait for replacement. You're having to wait so long for delivery on some of these vital assets now, and just the sheer downtime costs and the inconvenience of not having that asset. So I think you will agree that the customer had good return in value for using infrared sensors there. We move on to the next application, and we're talking about buzz duct. And Athol did sort of brief you just shortly about buzz duct, but as with all pieces of equipment, there's got to be some vulnerable area. The problem that you had with buzz duct, and we're focusing on sandwich type buzz duct, but the problem's fundamentally, if you have a lot of heat rise and decline, or if you're in a vibration, if you have a lot of vibration in the area, or even seismic environment, or if they're hanging from ceilings, it could potentially cause movement of those joints. So we have solutions, and there aren't many solutions on the market, let's face it. So we have a solution in various different forms, which will allow us to monitor all of those joints. Now we can 24/7 monitor, and the way the system's set up, we want to know what each sensor is doing. We want to know what our neighbors are doing. In fact, I'd like to know what the whole street is doing. So we can tell you when any of those sensors have actually picked up a problem, because you've got that movement and that hotspot is developing. Everything can be connected into your SCADA, so we can work with you to sort of make this solution fit your applications. Now, over the last 12 months, we've been collecting all sorts of case studies and hearing about horror stories. And we identify that, you know, hospitals, a really vulnerable environment. We had an old age pensioners ward actually caught fire. Airports, the fundamental problems that they have to face every year doing the thermography, when half of the buzz duct is through the ceiling. So it's hard to reach areas. So surely 24/7 monitoring, that would really take away peace of mind. Tower blocks, we've got one customer who actually, he had a contract, he's got 20 years, and they have to do the thermography of over 5,000 joints twice a year. If you install Exotherm, it would have paid for itself after 2 installs. Tap-off boxes and end boxes. This is really becoming a known problematic area, and actually has been the root cause on a number of major incidents that have broken out. Facility maintenance for data centers, for instance. Our intel tells us that one data hall itself alone could cost around $45,000. And remember, this is only one time. Our system would pay for itself after 2 thermography scans, and you will have peace of mind knowing that all of those critical busbar joints are being 24/7 monitored. So reach out. Why would you not install it? Okay. Next product is MCC, or motor control drawers. And we're talking about whether we've got an ANSI, a bucket, or whether we've got an IEC drawer. Now, first of all, let's look at the problem that you face, and then we'll just put in a solution. The problem is maintaining that vertical buzz bar. You want to know how healthy that buzz bar is. So, and it's all the challenges to do that maintenance and all the downtime costs connected with doing that thermography scan. So if you had a solution fitted in the drawer, which would 24/7 monitor, then surely this would be a huge cost saving for you. So what we have, it's a pre-wired sensor loom, fits into the drawer. We're monitoring the main incomers and the main outgoing, fitted into a data card with an LED light on the front of the drawer. And when all this is energized, when it's all powered up, when it's all energized, the sensors will 24/7 monitor that vertical bus. No need to keep doing that thermography scan. No need to keep removing the drawers. Every time you open and close the drawer, you actually weaken the forks at the back of the drawer, which are connected into that vertical bus. We hear so many stories about those fundamental problems where the weakness is at the back of the drawers. So we have a case study. Just one thing I just forgot to mention. Sorry, Athol. I always like to throw confusion. The sensors are monitoring not just the back of the drawer, but they're monitoring between the phases. So we'll monitor, we're looking for an imbalance within the phase and also for phase imbalance. So if it's a true MCC feeding a motor, we can actually identify that you've got a phase imbalance situation from there. Case study here, customer 45-year-old assets. So on paper, they should be replaced. Unfortunately, it will take 20 years just because of the sheer volume, but will cost over $1 billion. And let's face it, no one just has that disposable budget. In the meantime, the customer is still doing the thermography, is still losing that valuable downtime to do that thermal scan at the back of the drawer. And again, they're weakening the infrastructure. So we've started a rollout plan with this customer by installing sensors. Immediately, the customer doesn't need to do the thermography. And it can roll out as to which is critical and which is not. So he may not decide to do every draw. And this is where you, as a customer, you have to identify if an asset goes down, what would be the cost to you? What would be the inconvenience? So by putting sensors in the drawer, we can maximize his uptime, which that's pretty much paid for itself straight away. We're going to extend the life of the asset to allow him to formalize a plan to actually replace these assets. And I'm sure a lot of people in this call will identify this same problem. And for $600, sort of approximate figure, you can have a solution in your drawer, which will allow you to put that rotation plan together. If you've got issues with contactors because they're hard to reach, then you can also consider a second set to monitor across those contactors and a second LED light on the front of the drawer. So why wouldn't you do this?
Yeah, thanks, Carol. That's really, really interesting. I mean, it's so nicely ties back to the way we see the trends and drivers, how sweat your assets for longer, people be able to build a plan. So moving into the next question for everyone on the line, what do you consider the most significant benefit of predictive maintenance in operations? So give us your answers in the poll. Let's go through that as well. And please also questions, don't forget, throw them in the chat box so we can get to them at the end of the webinar.
So just to repeat the question, what do you consider the most significant benefits of predictive maintenance in operations? Is it the reduced downtime, the lower maintenance cost, the increased equipment lifetime, or the improved safety? Actually,
The all three, maybe.
it's almost a trick question, actually, because I
Yes.
think it's everything. So I can see why the numbers are actually sort of changing. So yeah,
I
there's
think
still a few more
most
coming
of
in.
our
Shall we
people have.
close this off?
Yeah, I think we can close it. I
Yeah.
think most people have answered there. Thanks, everybody. So what are we seeing there, Caroline?
Yeah, we've got 54% of you said reduced downtime. The second came the increased equipment lifetime, which came in at 25% of the votes. Improved safety was 17%, which, okay, I'm quite surprised, I think, with that statistic. And 4% the lower maintenance cost, which also is interesting. So, yeah,
Thanks.
brilliant. So reduced downtime. Okay, great.
Great.
I'll close
And
that
that's
poll
what we
off.
want to achieve. That's great. So thanks for that, Caroline. Thanks, everybody. So moving forward into just some happy customers, and this is just to give you a flavor in terms of some of the customers that we've worked with, where they've tried and tested our sensors and have basically also put it in as a standard for them as well. So if you look at the applications where we had infrared sensors in refining, upstream oil and gas, these are also white papers that have been presented based on the trials and the work with Exotherm and these end users. So, really, really nice way of saying Exotherm is the way to go. On the next ones, we play again in marine and data centers, specifically where people are putting Exotherm as a standard in there, as Caroline said earlier, in terms of putting it into your spec. And these guys are making it part of their spec now, where it comes standard fitted with Exotherm sensors to help them, as you say, increase uptime and reliability, keep their assets safe, etc., and their people. So what I like to see about this, and I think for me, Caroline, that stands out for me, is that exotherm can be used across any segment, any industry,
Yes.
retrofit
Yeah.
or new build. So, that really pops
Yeah.
out nicely to us. So, really thanks to all the customers that have
Definitely.
worked with us, and for you guys that are maybe new to work with us as well going forward in the future. So,
And I think that's key, actually, the fact that, the sensors can be used in so many different applications. And, our focus is on looking for problems. We want to take the pain out of some of the fundamental issues that you experience. We want to help you look after those assets for longer. So whatever your pain is, please reach out and let us see whether we can put a solution together for you. And just one more consideration, some of those remote areas where you can't get out in the desert, substations in the desert, in a wind farm 300 meters up in the air, on these offshore platforms, let's work with you to integrate sensors into all of your assets so that we can sort of work with you to put the solution as to how we can actually, help you formalize your maintenance plans, because that's what the sensor will do. Prioritize.
thanks, Caroline.
Sorry,
No,
I get
good.
very
Thank you
passionate.
very much. No, good points. Good points. So last poll for the team on the line really is just which topic beyond these previous webinars would you like to see us further explore? And looking into 2025, what would you like us to discuss? So please give us your answer. If it's not there, the topic's not there, put it in the chat box later as well for something that we can look at into 2025.
So we've got understanding the technical landscape, measuring delta T, how to future-proof critical electrical assets, and predictive maintenance using continuous thermal monitoring. And as Athol said, if there's applications or if there's anything specific that you would like to see, or even products, if you want us to, if you've got a problem area and you need solutions, then please share it with us. And by the way, we're always interested in case studies. So case studies is something that, if anybody's willing to do case studies with us, then please reach out.
Yeah, thanks,
Okay.
Caroline. I think the bars have stopped moving, so maybe launch the results for us. Tell us what was the answers.
Yeah. Okay. So let's have a look. 53% of you said how to future-proof critical electrical assets, followed by predictive maintenance using condition thermal monitoring. That came in at 49%. And then understanding the technical landscape, 32, and measuring delta T, 19. We did such a great job on our previous webinar on the delta T. So well done, the team.
Thank you, everyone. Thanks, Caroline. Thanks for that.
Okay.
That's
Thank you
really
for
great.
that.
Thanks, guys, for your answers as well. And of course, please submit it in the chat box too if there's something we haven't got there. We look forward to that as well. So just really recapping on what we've covered today is, firstly, that exotherm solutions can be used to safeguard all critical electrical asset connections, across your power distribution network, I think is important. The next thing is there's no limitation to where exotherm can be installed, which segment, sector, product, installation, new build or retrofit. And I think really, Caroline raised the point that we can provide a payback within 2 years, versus performing thermography and or installation hour window or installing hour window. So it's your payback's pretty quick. So for the financial guys out there, it helps us engineers hopefully put a good return on investment case forward when we're looking at these. And I think the last point is really, Caroline put it succinctly across to us earlier, was that selection plays a pivotal role, in your sensors. Selecting the right sensors prevents added additional maintenance, calibration cycles, to the selected thermal monitoring system you choose. So really the sensor selection, it really plays a vital part. So I thank you for that, guys. And really, Caroline, I thank you as well for your time and your efforts as well, and all your insights.
Thank you,
So
Athol.
now what we'd like to do is go to our Q&A. And thank you for your time as well to everyone on the call today. David, back to you, sir.
Wonderful. Thank you, guys. Excellent session. I hope the audience have appreciated the knowledge that the two of you have imparted there. We've got a whole stack of questions. There's no way we're going to get through all of them in 12 minutes, but let's see what we can do. Let's go at a pace. So first one up is, can you share PowerPoints of the webinars? I don't think we share PowerPoints. We share recordings of them afterwards. They are available. The previous ones are all available on the website under the resources section. There's a menu item called webinars, so everybody can grab those there. So let's pick a few out. One here. Why can't I use a camera to scan the connections in MCC drawers? Surely we can see them.
It's the back of the drawer that's the problem, because typically with MCC, when you scan the drawer, the scanning gets into the drawer, but where it doesn't reach is the back side of the drawer. So this is where the customer now has to de-energize. He's having to remove the drawer so he can put the camera to get to the back of the drawer. But two things are happening. One, it's the sheer cost of the downtime to do that for every drawer. And the second thing is that once you de-energize, the temperature is cooling down. So you're not actually getting accurate temperatures. So this is why installing our sensor loom, pre-wired sensor loom, into the drawer will actually 24/7 monitor all those connectors at the back of the drawer.
Yeah, and I think I would also
add that answers the question.
Yeah, I'd also add in terms of, Dave, in terms of a lot of these drawers, if you have a door that you can open and it's still live, you then break in that, let's say, that arc barrier where the guys, if there's a flash, it could come flashing out at the guy who's doing the thermography as well. So, if you have sensors, you don't ever have to have that door in front to then open up to do thermography either. So that's why I would say, I think what Caroline said, and making sure that you keep your people safe, not working where it could still be live and an opportunity for some fault to blow out into the operator.
Good answer.
I saw a question about artificial intelligence. How can artificial intelligence help? Okay, I could probably just take add a little comment towards that. We're not artificial intelligence, but the digital is the first step. So the sensors enable you to extract the data. We can take the data to wherever you want it to go to. And then it's the methods that you have in place to utilize the data to then trigger an artificial intelligence response. So we can contribute to the actions, but we're not the action, if that makes sense.
Yeah, great answer, Caroline. Really, the fact, if you've got a sensor, you're getting digital data, you can then take that back and do as many, run the AI in the background to analyze, predict, etc. So I think it's really great what you said. We can provide you with the digital information for that AI backbone to then give alarms or maintenance plans, whatever. So really good. Thanks.
I think a great man once said to me when I joined Exotherm, no sensor, no data. So you need that legacy information in order to be able to extract trends. Without it, you're basing your analysis on nothing. So
wise man, wise man.
Indeed. Another one here. Do we need to calibrate IR windows over their lifetime if they degrade? So that's calibrating. A question about IR windows specifically.
Yeah. Look, and I'm definitely no expert, but in terms of the reading and the understanding I have, is that with the crystals degrading, you should do calibration of those windows at certain times. So they do degrade, and you do need to do calibration, especially if it's the measurements. So each of them has a certain maintenance plan in terms of doing that. So because of the degradation of the crystals. So I mean, we can put some links If we want, Dave, we can put some links to that type of topic with pleasure in the answers.
Absolutely, absolutely, and
I
invite
see.
anybody on the call to come back afterwards and connect with
Please,
Atom
yes.
and Caroline for further in-depth information about any of the lineup that you've seen today.
Oh, people who know me, I don't struggle to talk. I get so passionate about this technology, so feel free, reach out. I noticed one of the questions, are the IR sensors resistant to dust? I think there's one fundamental important factor with the when you're installing the IR sensors, and that's to make sure. So we'll assume that this is the sensor, that the sensor is installed horizontal to vertically downwards. Okay, so when it's installed in any of those positions, then dust will not settle. You won't need to do any maintenance. You won't need to dust it. Okay, if you're in the equipment and it's something that you choose to do with a very soft cloth, but it's not a requirement. If you installed the sensors in an upward direction, which is against the manual, okay, we do not advise you to do that, then you know, some of the regions that I work with is very dusty. So instantly dust will settle on the lens. So you've actually imposed a maintenance process now. So stick to the manual, horizontal to vertically downwards, and you won't need to do anything to that sensor. And we've got these installed out in some very aggressive applications. We're out in the desert, we're on icebreaker vessels, you know, so you've got different temperatures, different environments. So hopefully that answered that question.
I can add to that. I can qualify that as IR sensors are rated to IP67 and NEMA 4X. That's straight from the CTO. So,
Thanks, Dave.
Is there a
um,
is there a new buzz duct monitoring product at the moment? I'm not sure if the question is asking about exotherm or in general, but there's very few solutions on the market. And we have different ranges. So we're looking at monitoring for long lengths. So if you've got straight lengths, then we can do a 24-meter length with embedded sensors every 3 meters. So if you've got shorter sort of shorter lengths of buzz bar, then you would coil the excess cable to make sure that the sensor does actually fit on the joint. If you've got a lot of different cut lengths, then we can do a more modular range. So reach out to us and we can give you more information specific to your requirements on that. Is there any specific climate condition for the healthy and long service life? I would say the answer to that is no. We're actually, the sensors are suitable for all climates. And as I mentioned previously, our sensors are installed in some pretty aggressive environments. So if the switchboard or the switchgear can actually withstand it, the sensors have been tested way beyond.
there's another question here about the dry type transformer case. So implementation with exotherm sensors. How much was the temperature difference measured by temperature sensors embedded within the winding and sensor outside the winding? I'm not sure whether you're going to be able to answer that, but maybe you can talk around that.
No, I'm not sure that.
I don't think we got. Did you get that?
John
I
would
don't think.
kill me if I even tried to answer that question.
Yeah. I don't know if we got that
No,
information from the customer between what his winding temporal saying versus what the tap change or the resin post was saying. So I'm not too sure. That's something we could look at, Caroline. It might be. It's actually a good question.
Absolutely, absolutely.
I mean, if we're comparing sensors, sensors are already built in. So the PT100 reference in the questions, they're installed inside of the transformer. And we're not touching any of those. We're not adding our sensors inside of the transformer at all. We're actually standing away, monitoring those critical coil tap changes via delta T methods. So if the person who's asked the question has actually got a case, then again, reach out to us and let's have that discussion.
Absolutely. Guys, we're up on the
What do you
hour.
think?
I'm going to suggest we wind it up for our audience and invite them to ask further questions directly with you in follow-up.
Thanks, David. Yeah, no, just a big thanks from my side to everyone who joined today. And a big thanks to you, Caroline, for helping us out here today, and to David and the team. It's always great to get out and have a chat to everyone. And please feel free, LinkedIn or via, if you have our Exotherm emails, please reach out. From my side, thanks.
And from my side too, I mean, I look after the Middle East, India, sort of Pakistan regions, and so if ever you want to reach out to me and you want to meet up and you want to know more about us, and also Lunch and Learns. Lunch and Learns, if anybody's interested, if there's many consultants on the phone, let's delve into some Lunch and Learns together. So you tell us what you want, and as teams globally, we'll work with you. So the more we share the news about how the benefits of continuous thermal monitoring sort of get out there, then the better we can work with you on your specifications. So, and that's the important part, your specifications. If you live them too loosely, then you could have anything. But thank you to Athol. Thank you, David. I'm
Thanks,
Precious in the
everybody.
background.
Have a great day.
Thanks, everyone. Have a good day.
Okay.